welcome to 6th grade math class, everybody. Last class of the day. The first thing I would like you to do is get out a piece of paper and a pencil and your calculators that I'm going to pass out to you. We won't need the calculators for a while, but we'll have them ready when we do. And I think they all work. If they don't, get you different. The first thing I'd like you to do is look at the table in the front of the room, and you'll notice different objects, and I'll separate them a little bit here. The first objects you see are coins, quarters. Then we have a bunch of dice, and then we have a bunch of cards. So I'm going to ask you a few questions about these three objects, and while I do that, I want you to think about how these objects are kind of related to each other. There's a common thread that I'm going to try to lead you to with these three objects. So the first is flipping a coin. I want you to imagine you or I take a coin and we flip it in the air 100 times. Take a guess. How many times do you think I might get heads? And you can say the answer, you don't have to raise your hand. 50. Everybody agrees 50? We're going to get exactly 50. No. What do you think? 60. So we probably won't get exactly 50 or exactly 60. It might be somewhere in the middle. What would you say if I said I had a coin and I flipped it and I got heads 87 times out of 100? What would you think?
Let me see that close.
What? Okay, the coin is broken. It could be like an on-fair coin. Maybe someone has like it's loaded. It's way down. Someone's like going to Vegas. Or what else could be true about that? Okay, I might be like cheating or lying. Maybe it really didn't happen. So that's the coin. Is this a touch? The next object are dice, okay? Same idea here. I pick up 2 dice and I throw the dice 100 times. How many times do you think I might get, say, a 7? Random guess. 6 times out of 100. 8 times. 15 times. Uncertain, right? What if I said, which would I roll more of? A 7 or a 12? What would you think? A 7. Why would you think that?
There's more chance of it. You could do 4 and a 3 or 4 and a 3 or 2 or 5 and a 6.
Good point. There's lots of ways to make a 7. What about the 12? How can you make a 12? There's only one way. That's a good point. So again, if I was to roll dice and get 12, 12, 12, 12, 12, you might say there's a problem here. Actually the next object I don't have, so I have a picture of it. A spinner. If I was to spin a spinner, what do you think I'd land on most of the time? Based on this thing? Red. Would I definitely get red most of the time?
No.
Not definitely, but most likely. Why would that be the most likely result?
There's more reds than there's any.
Yeah, there's mostly reds. Have you ever played Chutes and Ladders? Where you flick the little thing? Have you ever had a spinner that like is kind of bent in a weird way and always gets stuck on the same thing? So imagine you're playing Chutes and Ladders with someone and you keep getting like the yellow, and that's bad for whatever reason. You keep getting yellow and yellow, and you're complaining to the person you're playing with, I keep getting yellow, this isn't fair, and they say, you know, you're just a baby. It's not true, you're unlucky. How can I prove to that person that I'm not just unlucky, the spinner doesn't work right? How can I prove that to the person? What? How?
Because you don't have a yellow, so it should have landed as yellow on yellow.
Sure. Good point. It shouldn't land on you all the time. So what could I do to prove to that person that it is constantly landing on yellow all the time?
Do it 100 times.
Yeah, do it 100 times. Do an experiment. Show them, look, again and again and again. Last example are the cards. Has anybody ever played cards, games? What are your favorite card games?
Blackjack.
Slapjack.
Blackjack. We have some gamblers in our district. Ball.
Whoa. Scott.
Who said blackjack? So let's take our same situation, we deal 100 hands. How often do you think you're gonna get blackjack?
Out of 100.
Yeah. Just a guess.
Come on, Ray. 20.
Maybe 20. Poker player. How often are you going to say play Texas Hold'em poker or what type of poker?
Whatever.
Okay, so if you're playing Texas Hold'em, how often do you think you get, say, ace as your two pull cards?
1 out of every 100 ball.
We're not going to deal in exact, expected, precise numbers today. We're gonna deal with chance. What could happen? Can anyone sort of guess the common theme we're dealing with the coins, the dice, the spinner, and with the cards? Gambling is an idea? In a way, yes. That's chance, probability. You guys are very smart students. We are going to deal with probability, which is sometimes a big word, and we see it and we go, this is going to be a lot of math, this is going to be a lot of fractions, this is not going to be fun at all. But as you think about probability, think about the definition. This is the most basic definition of probability, if you can read this. How likely is something to happen? That's all it is. So, we're going to talk about a specific type of probability because there's more than one type of probability. The type of probability we're going to talk about is experimental probability. Anybody have a guess what, if probability means how likely something is to happen, what do you think experimental probability might be hinting at? Any thoughts?
Experimenting.
Yeah, experimenting. That's exactly right. You just cover up the A and the L. There you go. You're going to actually do an experiment. You're not going to guess. You're not going to do fancy mathematical equations or calculations. You're just going to do an experiment and record your results. Okay, so to illustrate this point, I need one volunteer who is pretty confident in their ability to flip a coin. You have to touch the coin?
Catch it.
Catch it? No, you could shake it and drop it or do whatever. You want to do it else? You look hesitant, so I want to empower you. Okay, whoops, sorry. The rest of you, I hope have your pencils out because you're going to collect the data on this. This is going to be a very brief experiment, but we need to keep track of what happens. So here's a little sheet. Look at the sheet, and it should be fairly obvious how to fill this sheet out. But first, as a class, we do need to decide here. What do we want to count? Do we want to try to get heads or do we want to try to get tails?
Heads.
Tails never fails.
Okay, let's just vote. Who wants to do heads? Who wants to do tails?
Serious.
I think there's slightly more women are female, so we will go.
Go on.
Wait, what did you say? Heads? Okay, we'll do heads. So, if we roll a heads, just make a little tally mark on the heads. If we roll tails, on the tails. Okay, first look, go ahead. And just call out what you get on it.
Is she gonna catch it?
Tails, mark it, please.
Heads.
Heads.
How many times did I do this?
Let's do 10 times.
Let's do 100.
Tails.
Yeah.
Maybe you should do maybe you should throw it on the table.
Heads.
Just drop it.
Tails. Heads. Tails.
Can somebody tell us when we get to 10 also?
Give it a chance to bet one.
Tails.
One more.
Oh.
No.
Tails.
Are we done?
Oh, I had 9.
Seven and 3.
We have 10.
That's how we do that, Tim? It was nice.
So on the board, I'm going to write something that's roughly going to mirror what your paper looks like. We have heads and we have tails. Somebody who is very good at counting, what do we get for heads?
3.
3 heads. And how many tails?
So,
7. So now that we have our data, this is our data we've collected on our experiment, we do need to know how to write that as a probability. There's 2 basic ways to write our results. And today we're going to learn how to write experimental probability as a ratio and as a percent. Just those 2 things. I think you'll find it's not very difficult once you get the hang of it. Is anybody familiar with ratios? Anything pop into your head when you see ratio? Yes?
Fraction.
It is. It's just like a fraction. And we all know a fraction looks like there's a number here, a numerator, a line, and a denominator. That is what our probability will look like. It'll just be a fraction, except there won't be zeros in it. So we need to know what to put on the top and what to put on the bottom. On your piece of paper, I do want you to write this because we're going to use this again and again today. On the top of our fraction, probability equals. On the top of our fraction is the number of times the event, that's the key word, I'm putting it in capital letters, happened. The number of times the event happened. Looks like a very big numerator, but it will just be one number. The number of times the event happened, that's the numerator. On the bottom is the number of trials. Does anybody know what we mean by trials?
Did something.
Number of times you do it.
Yeah, the number of times you do it. So the top of the fraction will be the event. What is the event for our data? The event is what we were counting, heads. The total numbers of trials will be the total times Ellen flipped that coin. So is anybody smart enough to have already figured out how we would write our probability for our experiment as a ratio? This is as a ratio. Throw it out there.
3 over 10.
We got heads 3 times. Our total number of trials was 10. Very nice. That is exactly what our ratio is. Now let's think of a different experiment where maybe Ellen flipped it and she got 5 heads and 5 tails. What would that ratio be? Good, 5. We have 5 heads, assuming we're counting heads, and 10 total flips. What if we had 6 heads and 3 tails? Totally different experiment. We flipped the coin, we got 6 heads and 3 tails, and now we're counting tails. What's the ratio of tails that we got? 3/9. Good. The denominator changed because now we only flip the coin 9 times. Everybody pretty clear on the ratio part? Good. The second way we write our probability after the ratio is a percent. The way we write a percent is we simply use the numbers that are already in our ratio. We take the top number as a percent. You take the numerator, which would be 3, divide it by the denominator. You do that first. Get a number, and you multiply that number by 100. So everybody, take out your little calculators, please. And please punch in 3 divided by 10, get an answer, multiply that answer by 100, and that will be the percent of our flips that were heads. Anybody get it? Andy? 30. Is everybody clear on that? Because, yes, in the back.
Yeah, Mr. Burns said we're not supposed to use calculators. That's an easy way out, but it's wrong. We should use our brains.
That's a good point.
He said it's wrong to use calculators. Why are we using them?
The reason I chose to
He's
use
a cool teacher.
Is he? That's great. Yeah. The reason I chose to use calculators today was my main concern is not whether you know how to divide or multiply. My concern is that you know the process of how to turn a ratio into a percent. So even if you didn't know how to multiply and divide, I really wouldn't care today. I'm more interested in making sure you know how to turn that ratio into a percent.
But don't you care if we know how to multiply and divide?
I do,
You just said you didn't.
but today I really don't. So it's kind of fun and exciting not to have that as a responsibility.
So is Mr. Burns right?
What did he say again? I forget
He said it's
exactly.
wrong to use calculators because we don't use our heads anymore.
I think there are times it's wrong, yeah. Like if you were taking a test on multiplication, it would definitely be wrong to use a calculator. So I would agree with him in that situation, yeah.
So shouldn't we practice today and just not use these calculators?
Maybe there'll be times when we won't use them, but I think today we'll go ahead and stick with them. Does
Okay.
that sound okay?
Okay.
Okay, good. Is everybody fairly confident in calculating the ratio and the percent? Because you're gonna have to kind of do a little bit on your own at this point. So if you have any questions, please voice your concern. We're gonna move on to dice. You're gonna need to get with somebody next to you, so let's put Scott and Andy together, back 2, back 3, and 2 right here. I'm gonna give everybody 2 dice. In fact, what if one person from each group just come up here and go ahead and grab 2 dice? That's fine.
Do we have to be the same size?
No, it is your choice, Scott. Have some fun with it. Mix and match.